Hello there. I'm speaking to you today, on this day in the year 2026, from my home here in Oklahoma. I want you to take a moment and just look around you. Really look. See the light that fills your room? It might be the gentle glow of the sun streaming through a window, or it might be the steady, unwavering light from a bulb overhead. Perhaps you're watching this on a screen, a sleek piece of glass and metal that can show you anything from a distant galaxy to the face of a loved one thousands of miles away. The air you breathe is likely clean and comfortable, kept at just the right temperature by a quiet machine humming in the background. These are the simple comforts of our modern world, things we often take for granted. We live our lives surrounded by a kind of everyday magic. We can speak to people across oceans in an instant. We can travel faster than any bird could ever fly. We have medicines that can mend broken bones and fight off invisible invaders that once plagued our ancestors. We can grow more food on a small patch of land than was ever thought possible, feeding billions of people. This world, this intricate and comfortable reality we all share, didn't just appear out of nowhere. It wasn't wished into existence. It was built, piece by piece, idea by idea, by a very special way of thinking. This way of thinking is what we call science. Science is the engine of our civilization, the invisible force that shapes almost every part of our daily lives. It's in the food you eat, the clothes you wear, and the home that keeps you safe. It's the reason your car starts in the morning and the reason you can trust the bridge you drive over on your way to work. Yet, for something so important, it can sometimes feel distant, like a secret language spoken only by experts in white lab coats. It can be associated with complicated equations or people who see the world in a very different way. But the truth is, science isn't just for a select few. It's for everyone. It's a tool that belongs to all of us. The purpose of our journey today is to demystify this powerful process. We're going to pull back the curtain and show you how science really works. Not in a dusty old textbook, but right here, right now, in 2026. We will explore how this method helps us understand the world, from the smallest particles to the vastness of the cosmos. We will see how it is a process of discovery, a way of asking questions and listening carefully to the answers the universe provides. It's a story about curiosity, about humility, and about the incredible things we can achieve when we work together to find the truth. Every great scientific journey, every discovery that has changed our world, begins with a simple, humble step. It starts with a question. This is the first spark of curiosity, the moment we look at the world around us and wonder, why? What if? It's a profoundly human thing to do. A farmer might walk through her fields and notice that the corn on one side of the hill grows taller and healthier than the corn on the other. She asks, why is that happening? A parent might see that their child feels better after a bowl of warm soup when they have a cold and wonder, does the soup actually help, or is it just a comfort? These are the seeds of science. This initial step is called defining the aim. It's about focusing our curiosity into a clear, answerable question. It's not enough to just wonder about the world in a vague way. To make progress, we need to narrow our focus. The farmer isn't just asking about plants in general. She is asking specifically about her corn on that particular hill. Her aim becomes to figure out what makes the corn grow better on the west side of the hill. Once you have a clear question, the next step is to propose a possible answer. In science, we call this a hypothesis. A hypothesis isn't just a wild guess, like picking a random number. It's an educated guess. Now comes the moment of truth. You have a question, a hypothesis, a specific prediction. It's time to collect the evidence. This is the part of science we call the experiment, or the observation. An experiment is a controlled test you design to see if your prediction comes true. Once an experiment is done, we are left with something precious. We have the results. In science, we call these results data. Data is simply information collected from the real world in a structured way. It is the universe's answer to the questions we have asked. Data can come in many forms. For our farmer, her data might be a simple list of numbers: final height in centimeters, every single corn stalk, control group, every single corn stalk, experimental shaded group. For the parent studying chicken soup, daily ratings of nasal congestion from each person. Data is the raw material of understanding. On its own, a long list of numbers can be messy and confusing. It might not look like much, but to a scientist, this list is a treasure. Statistics is a field of study that can sometimes seem intimidating, full of complex names and calculations. But at its heart, it is simply a toolkit for thinking clearly about data. It helps us answer a crucial question: is the pattern I see in my results a real effect, or could it just be a coincidence? Human beings are excellent pattern finders. We see faces in the clouds and connect unrelated events in our minds. So, how does an idea go from being a tentative hypothesis to being accepted as a scientific fact? It happens through a process of building consensus. A scientific consensus is not a vote. It's not a popularity contest. It is an overwhelming agreement among scientists who are experts in a particular field. This agreement emerges organically over time, based on the sheer weight of accumulated evidence. It is the result of many different researchers in many different countries, independently conducting experiments and observations that all point to the same conclusion. Now, let's think about your breakfast. Perhaps you're having a bowl of cereal with milk, or some toast with a side of fruit. The abundance and safety of this food is one of the greatest, yet most overlooked scientific achievements of our time. A century ago, a significant portion of the population had to work on farms just to feed everyone. Today, a tiny fraction of our population can produce more food than we could ever imagine, feeding billions. This remarkable transformation is thanks to agricultural science, a field that applies the scientific method directly to the challenge of growing food for the world. The crops themselves, like the wheat for your toast, because science is so powerful and explains so much, it is sometimes seen as being in conflict with other ways of seeing the world, especially with religion or faith. There's a common stereotype that science is only for atheists, but this is a fundamental misunderstanding of what science is. Science is a method. It is a tool for understanding the natural physical world. It is a process for testing ideas about how that world works. It is not a belief system or a worldview in and of itself. Just as science isn't reserved for one particular worldview, it also isn't reserved for one particular type of person. There's a persistent stereotype, often seen in movies and television, of the scientist as a socially awkward, emotionally distant person, often a man in a white lab coat. This caricature is not only inaccurate, but it is also harmful. The truth is, science thrives on diversity. It needs people of all kinds, with all different ways of thinking. Ultimately, the only requirement to engage with science is curiosity. If you've ever wondered why the sky is blue, how a plant grows, or how your own body works, you have the heart of a scientist. I want to leave you not with a set of facts to memorize, but with a tool you can use every day. That tool is the power of asking a good question. This is where all science begins. It is a skill that every single one of us can cultivate. It is the simple act of not taking things for granted. When you hear a claim on the news, or when you hear it from a friend, start by asking, how do they know that? This is the first step in thinking scientifically. It shifts you from passively accepting information to actively seeking the evidence that supports it. One of the most profound lessons the scientific method teaches us is about our own minds. We are all, without exception, prone to bias. Confirmation bias. Seeking out information that supports what we already believe, ignoring information that challenges it. We are prone to seeing patterns where there is only randomness, swayed by compelling stories, swayed by charismatic personalities. The scientific method is a set of rules we created to protect ourselves from our own flawed ways of thinking. The world we inhabit in 2026 is, in a very real sense, a world built on evidence. The reason your building stands, your car runs, your phone connects to the internet, is because countless people followed a process of testing ideas against reality and kept the ones that worked. This principle, of favoring evidence over authority, tradition, intuition, is the bedrock of our technological civilization. We have come to the end of our time together. I hope this journey has helped to demystify the process of science and has shown you that its heart is not in complex equations or fancy equipment, but in a simple, profound, and very human spirit of curiosity. It is the spirit of a child asking why, over and over again. It is the spirit that drove our distant ancestors to look up at the stars and wonder about their place in the vastness of it all. This spirit of wonder is your birthright. It belongs to all of us. Science is simply a way to honor that spirit with discipline and care. I invite you to carry this sense of wonder with you. Look at the world with fresh eyes. The world is not a mundane place. It is a place of infinite wonder, and it is a story that every single one of us has the power and the privilege to be a part of. Thank you for joining me.